Question 7. List the following bonds in order from weakest to strongest. So when we talk about different types of bonds in chemistry, whenever you see a question like this, it's a good idea to think about all the bonds that you have learned and a general order of which one is stronger than which. So the weakest one, and in general, intramolecular forces should be stronger than intermolecular forces. So the weakest would be the weakest intermolecular force, which is dispersion force, which I'm not going to go into what causes it. And the next one will be dipole-dipole, followed by, I am not going to have enough room, am I? Followed by hydrogen bond, and followed by covalent. Now, obviously, when I say that covalent is weaker than ionic, which is weaker than metallic, that is a very, very general statement, because we all know that diamond, which is the strongest substance existed, actually consists of covalent bonds, but that's a covalent lattice. So if we talk about covalent in the context of a molecule, then it tends to be weaker than the collective in ionic or the collective metallic forces in lattices. I'm going to start with covalent because by the look of it, none of these are ionic or metallic. So if we use this quick guide, hopefully we should be able to work out a few. So we're going to see permanent dipole-dipole, yes, covalent. So dispersion forces should be the weakest. Now we have two dispersion forces here. You have number 3, which is dispersion forces between atoms of helium. So helium is a noble gas. So the atoms don't actually form molecules. And then you have dispersion forces between molecules of carbon dioxide or CO2. Now, if you think about which of these two dispersion forces would be stronger, that should be CO2, because even though I just said that I was not going to go into what causes dispersion forces, if you have more atoms or you have more electrons, and obviously CO2 would have more electrons than helium atoms, you have a higher chance of having dispersion forces. So the weakest one in this bunch should be number 3, which is dispersion forces between atoms of helium, and followed by number 6, dispersion forces between molecules of carbon dioxide. So once we cover the two dispersion forces, we're going to look at dipole-dipole. So there's only one dipole-dipole here, and the rest is you have a hydrogen bond and you have two covalent. So I think the dipole-dipole will be the next one. So dipole-dipole will be stronger than the two dispersion forces, and that should be followed by the hydrogen bonds. So I have number 4. Now you have two covalent bonds left. We have the covalent bonds between carbon and hydrogens, and covalent bonds between nitrogen atoms in nitrogen molecules. It's very hard to sort of know which one is stronger if you just look at it like this. So one of the way to think about it is to draw the structure out. So I'm going to use the structural formula here. So each carbon have one covalent bond with a hydrogen. So that's covalent bonds between carbon and hydrogen, which is that. And then if you think about what actually happens in nitrogen, each nitrogen atom actually forms a triple bond with the other nitrogen atom in a nitrogen molecules. And the reason for that is because nitrogen has, I think, 7 valence electrons. So it needs 3 more in order to complete the outer shell of it, which is itself a very, very rough rule of thumb, but that's okay. So number 2 should be weaker than number 5, just because this is a triple bond and that's only a single bond. So that would be the correct order from weakest to strongest. And I do not know why my handwriting is not straight. But anyway, that's question 7.